Okay, the next problem I want to look at, which I'll call application 2, is a question also in 4E. I've got 3 question types in here I want to look at. I'm going to jump down and look at question 7. Okay, what does question 7 say? It says this: the integral from 1 to 0 of e to the minus x squared dx. And what we need to do is we need to use a 4th degree polynomial to approximate that. Okay, let's do that. So I'm just going to write down, first of all, I'm just going to write down what e to the x is as a series. So I've got 1 plus x squared on 2 plus x cubed on 6 plus dot, and then I want to substitute in, replace x with minus x squared. So I'm going to have e to the minus x squared equals to 1 minus x squared plus x to the power of 4 on 2 minus x to the power of 6 on 6 plus dot. Okay, and what I now need to do is I now need to do that integral. So I'm now going to integrate that. So now I only have to use a 4th degree polynomial here. Yeah, I only have to use a 4th degree polynomial, but I will write in this one just to show you something. So what I'm going to do is I'm going to do the integral of e to the minus x squared dx as being approximately equal to, because we're only going to use the first few terms, the integral of 1 minus x squared plus x to the power of 4 on 2, okay, minus x to the power of 6 on 6 dx. Now I only have to use the first up to an x to the power of 4 term, so I'm only just going to integrate up to there. Let's do that now. Okay, so I'll do that integral. That becomes x minus x cubed on 3 plus x to the power of 5 on 10 from 1 to 0. Which equals to 1 minus a third, yeah, plus a 10th, which equals to 23 on 30. Okay, so there's an approximation for that integral using the first 3 terms. How far are we at? What's an upper bound for that error? So I'll just see if I can reduce this and stick that there. What is an upper bound for that error? Now, if you look closely here, and I'll just grab another texter. If you look closely here, we've got plus, negative, plus, negative. This is an alternating series, and we know that the error term for an alternating series, we're pretty lucky, the error term for an alternating series is less than the unth plus 1 term. Yeah, so I've just got to really integrate this next term between 1 and 0, and that will give me an upper bound for the error term. Okay, so what I'm going to do is integrate between 0 and 1, x to the power of 6 on 6 dx, which will equal to x to the power of 7 divided by 42. And that is between 1 and 0, and of course that equals to 1 on 42. Now we just have to be careful because in the answers they've got some crazy answer written, but I think that works out to be, look, I'll just do it on my calculator. Yeah, I get on my calculator 0.0238, and it's expressed to the powers of minus 10, but I think they forgot the actual power. It's 2.38 times 10 to the minus 2. So that's what the answers should actually have for that particular question. So that's the another application of where we can do integrals that we can't normally do. We approximate them. That's not terribly accurate, but certainly if we took another couple of terms, we could get a much better approximation to that integral. Okay, that's applications video number 2.